Cheers. We get false over? Oh, that's pretty good.
Wow.
It's a salad. It's a salad.
JC, that was delicious. Well, when you haven't had a salad in 6 months, it's delicious.
Still station on 2 for Nanorax.
With you on 2 for Nanorax.
Right, how's your view? Do you want anything different?
View looks great.
No, the view looks great, thank you.
Now that the experiment is aboard the space station, it's time for the astronauts to get to work. Elaine and Paris Stu are back in Virginia, and the Nanorax team is back in Texas, where they will perform a ground control version of the experiment being conducted by the crew in space.
The crew members are using the Nanorax plate reader to read the plates. They're analyzing what's in the plate and the migration of fluids between the 2 chambers that are on the plates. And so we have our ground samples here. These are identical to the ones that are on the space station. And what we're going to do is, as the crew members insert the plates into the plate reader on the space station, we're also going to insert the plates onto the ground unit we have behind me. And that's just to confirm that what we're seeing, any effects that we do end up seeing, is effective the space environment compared to the ground unit. In summary, what the plate reader does is, it's called, the big fancy word is a spectrophotometer. And it's got a big lamp in it that shines white light, and then it's got a prism or a grating. And the white light shines on the grating, and then it moves to orientate to kind of separate the light into a wavelength. And you get to select which wavelength you want to shine through your samples. We have 6 plates. Each plate takes about 4 minutes, so it's about 30 minutes each. And every time in between, we'll be listening for the crew member to say that they inserted the plate. Then we'll hit the command here. Once the run is done, the crew member will come over and take the plate out, put the new plate in, and it'll repeat for 5 more times.
Still station on 3, plate 1003 is in the tray.
Oh yeah, it's reading the plate. It's got a little, the plate sits in there, moves the plate this way, and then the read head moves this way. And a little here, that's kind of the lamp that's in there that turns the lamp on. Sounds like bad techno music.
My crewmate actually was the first one to start this experiment, and I took over for him and said, hey, what experiment is this? What are we doing? And he looks at me and he says, I'm not sure. So we called down to the ground, to Mission Control.
And I know that part of this is we're looking at a gel that can release antibiotics, kind of slow release to a wound site. But I don't know what happened to that plate in the Nanorax reader this morning, and then kind of what's going on this afternoon.
What we're looking for is how the drug migrates through the gel over time, which is why we're scanning the plates 2 times a day for this 2-week run.
I like that answer. That's very cool. Thank you for finding that out.
No problem.
So this is 15 days. It's twice a day, and they're typically in the middle of the night, which is the morning for the crew on space station, and then usually sometime in the late morning, early afternoon here. But Kyle's been running the show. He's been getting up every 6 hours, 8 hours, 7 hours to do this. It's kind of fun in a way. I get to play astronaut on the ground, so that's always fun.
After 15 days of running the experiment, the researchers have a lot of valuable data about how hydrogels behave in microgravity. To learn even more, the samples will come back to Earth for further analysis. For the last leg of their journey, the samples will return to Earth in the same Dragon capsule that gave them a ride to microgravity. After Dragon splashes down in the Pacific Ocean, it's taken to the port of Long Beach, where NASA will be ready to retrieve the precious cargo.
Splashdown for Dragon was on Sunday, I believe. And so NASA has a group called Cold Stowage and Cargo Manifest, and they go out and pick up the payloads from Dragon. And then they distribute it to people at LA or whoever needs them there, and then they bring them also here to Johnson Space Center. And so now I'm out front the Cold Stow office, and I just picked up Module 74, which is our Tim Panagen project. And they hand it to me, and I put it in my cooler, and then I drive it over to our office, where it's going to sit until we fly up to the Tim Panagen office in Richmond, Virginia, to do the final phase of the experiment, which is removing the samples out of the reactor microplates. We're really proud to take part in this really interesting experiment.
Hello, my name is Ayla. I'm in grade 9, and my question for you is, do astronauts ever get sick or ill aboard the ISS?
Ayla, when we first get to space, we feel sick. Your body's really confused. And so, you know, you're dizzy, your lunch is floating around in your belly because you're floating, and what you see doesn't match what you feel. So you want to throw up. So how do you throw up if you get sick in space? Oh, the sun's starting to come up. So here's an astronaut barf bag right here. So let's say you're about to throw up in space. Quick, you get your barf bag open. And now think about what happens on Earth when you throw up. Now that'll be okay. You throw up and you have a bag of something horrible, and then you throw it away. But in space, if I throw up in this bag, what am I going to do with it? This bag has to stay with me in space for months. So we want a really good barf bag. So we have one that will really protect us. And this one has a liner in it, so that when you throw up into it, you can clean your face off, and then you can push everything inside, and then it comes with its own Ziploc to put inside the Ziploc, and then you can throw it down into the wet trash. So yes, astronauts do occasionally get sick in space, but we have special barf bags to deal with it.
Hey, Mike here. Let's talk trash. What do we do with trash on the International Space Station? Several different ways. If it's just dry trash, paper kind of things, they'll go in a plastic bag that we fill full of, and eventually, once it gets full, we compress it, kind of wrap it with tape, and we put it in a bag to collect them, ready for one of the cargo ships to head home, and we'll push them in there. For the wet trash, though, leftover food packets and things like that, we have to pack that a little more carefully. So first of all, we'll take the bits of food and put them in one of the wrappers that hold the food portions of food, come in some kind of a foil wrap, and we'll take the leftovers. There's really not many leftovers as far as food goes. We just eat it all because you want to get the air out of there, and then you want to seal these up, and that's what's really great about these. They actually seal. It's made of the same kind of material that the lining of our spacesuit is made out of. And so it's really good, it's really tough, and it's good at sealing. And you seal it by securing, it's kind of like a rubber band that goes around it. You wrap it a bunch of times and then push this through, and it actually holds together in a surprisingly strong fashion. Kind of get that loop under the thumb. And the hard one to get started is the first one. There you can see that the bag is secured now with a pretty good area, and that won't let the air out, because this leftover food's going to sit up here for quite a bit of time, sometimes months, before the next ship is leaving to go burn this stuff up in the atmosphere on the way down. And so you just need to have it sealed as securely as you possibly can.
And to make sure you don't miss out on anything mind-blowing happening in our universe by subscribing. Thanks for watching.